Good day again to everybody. Let's continue with our lesson. So, in the last lecture, I have forwarded to you, I have given the discussion there of solids, wherein the volume is the area of the base multiplied by the height. So, basically, if you will look at those diagrams, or if you will be observant with the problems that we have solved there, the solids that we have considered there actually, if you will observe them again, the base that you are considering has a similar surface above it, which is just parallel to the base. For example, the cube. So for the cube, you have a square base, and then you also have a square above it, which is parallel the base. So that formula, volume of a solid, that is base times height, basically will be applied to those types of solids. So for today, we will be looking at solids wherein the volume is equal to 1/3 base times height. And for this particular unit, we will be concentrating on the pyramid. And a pyramid is defined as a polyhedron. So pag sinabing polyhedron, one face, which is called the base, is a polygon. So there is one base called the base, we have one base which is a polygon. And this polygon can have any number of sides. And the other faces are triangles which have a common point, which is called the vertex. So the triangular faces are called the lateral faces. And then the altitude of the pyramid is the length of the perpendicular line that is dropped from the vertex to the plane of the base. Okay, and then if we want now to solve for the lateral area, so by definition of the lateral surfaces, we look at the triangular surfaces. So we just get the area of those triangular surfaces. We get now the lateral area. And then the volume is said to be equal to 1/3 the area of the base multiplied by the altitude, basing it from the definition given earlier. So let's look at this diagram here. If you will look at this diagram, this is an example of a pyramid. So again, a pyramid has a base that is a polygon, that's a face, a base, which is a polygon, and then you have a point outside the base, which is called the vertex. Then if you now connect this point to each of the vertex, you now form your lateral surfaces. Okay, and then if you drop a perpendicular line from the vertex to the surface of the base, this is now called your altitude H. Okay, so that's the description of a pyramid. And we also have what we call a regular pyramid. So what's the difference of a regular pyramid? A regular pyramid is a pyramid wherein the base is a regular polygon. So what's a regular polygon? It's a polygon wherein the length of the sides are all equal. Okay? And then whose center coincides with the foot of the perpendicular, which is dropped from the vertex and again to the base. So if this is a regular polygon, or if this is a regular pyramid, then the base is a regular polygon, the sides are all equal, and then if you now drop your perpendicular line coming from the vertex, this point of intersection will now fall under the center of the polygon. So by the way, it was not defined in this discussion, but if we will just go over the definition again of a center of polygon, the center of the polygon is actually the same. The center of a regular polygon is the center of the circle that circumscribes the regular polygon. So if you will imagine the regular polygon, if you draw a circle outside the polygon such that the circle or each vertex of the polygon touches the circle, the center of that circle is the same as the center of the polygon. Okay? So that's the only difference of your regular pyramid with the ordinary pyramid. And of course, sabi rin dito, the lateral edges of a regular pyramid are equal. So these are the lateral edges. And then the lateral faces are congruent isosceles triangles. These are all congruent isosceles triangles. And then the slant height of a regular polygon, the slant height of a regular polygon is the altitude of a lateral surface. Since a lateral surface is an isosceles triangle, if you get the altitude, that must be perpendicular. So in this case, perpendicular with NP. This L here is what we call the lateral surface. And for your regular polygon, if you want to solve for the lateral area, so the lateral area is just the area of the lateral faces or the lateral surface. And if you look at one, uh, if you will try to analyze that, since one face is an isosceles triangle, you get the area of this, which is 1/2 the base times the, in this case, the slant height. That's the height of the, uh, uh, that's the height of one face. So 1/2 the base times the height. And then since your base is a regular polygon, you now form n isosceles triangles, diba? So you, like in this case, how many sides do we have for the base? 1, 2, 3, 4, 5. So you now form 5 isosceles triangles. So if you take the lateral surface of this, you get the area of one isosceles triangle times 5. So if you get the area, let's say, of this isosceles triangle, it's 1/2 base is NP multiplied by its height, which is L. But if you want now to get the total lateral surface area, since you have 5, if you multiply NP by 5, you actually get the perimeter, right? Perimeter is just the sum of the sides. That's why the formula given here is that the lateral area is equal to 1/2 times the perimeter times uh, the slant height. Okay? And then still the volume is 1/3 base times height. Let's look at now an example here. Again, this is in your module. I would just like to explain the solution given. So a pyramid VABCD. So you have a pyramid VABCD. So that's the pyramid, the one formed inside the cube, is cut from a cube whose edge is 12 inches. So one edge of the cube is 12 inches. So the vertex B is the midpoint of an edge of the cube. So V is the midpoint. So meaning it divides the edge into two equal parts. So if the edge of a cube is 12 inches, then this must be 6 inches. This must also be 6 inches. And what do we need to compute? Compute the lateral surface area of the pyramid. So that is what we want. Lateral surface of the pyramid. Remember, the pyramid here is not a regular pyramid. So if it's not a regular pyramid, we just get the total area of the lateral surfaces. So again, pag sinabing lateral surface, you exclude the base. You just get the uh, area of the lateral surfaces. Therefore, if we will now let's say, A represent the, so let A be the lateral surface area of the pyramid. So let A be the lateral surface area of the pyramid. So A, if you will look at your diagram, will be the area of triangle AVB, the triangle here, AVB, and then these two triangles here, triangle VAD and triangle VBC, but they are equal, right? These two triangles are equal, so that will be plus 2 times the area of triangle. Let's get triangle VAD. Anyway, pareho lang naman yan, VAD. Or if you don't like triangle VAD, you can have VBC. And then plus the area of the last triangle here, this one, VDC or DVC. That's just the same, DVC, DVC or VDC or CVD. Anyway, just that triangle there. Okay, so we need now to compute the area of each triangle. Let's look at triangle AVB. Let's isolate that. Area of triangle AVB. Where is that triangle? A, this triangle here. A, this one at the back. AVB. AVB. Okay, so the area of that will be 1/2 base. What's the base? AB times the height. So what will be the height there? We can, wait, I'll just fix that. I'll remove that portion there. Okay, so what will be the height here? We can draw a perpendicular line there. And maybe I can call this as point E. So that will be 1/2 AB times the height. What's the height we have there? Height VE. So question, do we know AB? AB is given, that's 12 inches. How about VE? V is not given, but if you will try to isolate one of the right triangles there, this is triangle VEB. What lengths do we have there? This is given to be 6 inches. Okay, so I'm just isolating so that you will see it. Isn't it that this is just equivalent to the edge of the cube? Therefore, this must be 12 inches. Therefore, this is times 12. So we now have the area of triangle AVB. Next, how about triangle VAD? What will be the area of triangle VAD? Okay, so that will be 1/2. We can take AD. We can take AD as the base here. We can take this as the base. 1/2 base AD. Sorry, that is AD, not AB. AD. That's 1/2. Where's the pen? 1/2 AD multiplied by what will be the height. So if you will analyze this, VAD, this must be 90 degrees. You visualize that? It's 90 degrees. So it means our altitude will now be VA. VA. VA will be our altitude. So the area of the triangle is 1/2 base times the height, which is VA. But where do we get VA? Isn't it that VA, look at this triangle here. Let's go back to triangle VAB. If I will draw this again, isn't it that this is your A? This is 6 inches. This is 12 inches. So it means we can compute for VA. So AD, again, AD is 12 inches. So this is 1/2 multiplied by 12 inches multiplied by VA. What will be our VA? So let's look at this triangle here. This is your A. By Pythagorean theorem, isn't it that VA is the hypotenuse of that right triangle there. So this must be 12 squared plus 6 squared. So you now have the value of VA from here. So just insert that value. So going back to our uh, list, we already have the area of triangle AVB, then the triangle of VAD, area of triangle VAD, finally the triangle VDC. What will be the area of triangle VDC? What will be the area of triangle VDC? Uh, VDC. So this triangle here. So if you will look at that diagram, VDC, this triangle here. So what will be the base? It will be 12. And then we can draw a line going here, perpendicular to this one. That will now be our height. Let's call this as point F. Okay. So the area of triangle DVC is 1/2 the base, which is DC, multiplied by the height, which is VF, which is VF. Do we know DC? DC, yes, it's 12 inches. How about VF? VF will now be computed from where? Look at this. I can connect this, forming another right triangle here. Your triangle VFE. So, if you will redraw that, V, F, and then E. You have V, F, E. This is 90 degrees. VE is 12 inches. And then EF, isn't it that's also equivalent to the edge of the cube. Therefore, VF is solvable. VF will now be the square root of, this is the hypotenuse of this right triangle, 12 squared plus 12 squared. So you have the value of VF there. Just substitute it here. Okay. Finally, if you already have the area of triangle DVC, go back to this equation, then you now get the total area. Okay, so that's the analysis for that problem. Just compute the necessary values needed there. So let's proceed to another problem given in your module. Find the volume of the regular square pyramid. The description, we are looking at a regular square pyramid. So regular square pyramid, it means that our base is a square. So we have 4 feet, 4 feet, 4 feet, 4 feet. And according to the definition of a regular pyramid, from the vertex, if you drop a perpendicular line, this must be 90 degrees. Perpendicular and it passes through the center. So kung center, this is equal to this one, also equal to this. Okay? Therefore, if we will now solve for the volume, volume is 1/3 the area of the base multiplied by the height. And clearly, the base is just a triangle, it's just a square. Area of the square base is we get the edge, we square it. So that's 4 squared times h. So our problem is, what is the value of h? If you will now isolate this one, okay, you will isolate that. Let's use this triangle, or let's use this diagram here para mas makita ninyo. That's your h. Di ba yan yung base? 4, 4, 4. Since this is a right triangle, if you will compute this red section here, it's the this section is the hypotenuse of the right triangle formed here. Okay? So if we will now call that, let's say, as x. X now will be equal to the square root of 4 squared plus 4 squared by the Pythagorean theorem. This is the hypotenuse of the right triangle. Or that will now be 16 plus 16, 32, or 2 times 16. Square root of 16 is 4. So that's 4 the square root of 2. That's the whole length of the red section. But remember, since it's a regular square pyramid, then this is the center of the square. Meaning, this side here is equal to this one. This side here is also equal to this one. So if the total length is 4 the square root of 2, you divide that by 2, then this section is 2 the square root of 2. That's where the value 2 the square root of 2 was obtained. It's just half of the value of x. So that's 2 the square root of 2. So going back to your diagram, this is 2. Let me use another color. This must be 2 the square root of 2. This is also 2 the square root of 2. Okay? And then 6 is given, the length of this section here is 6. That's why when you will isolate one of the right triangles there, this is 6, this is your h, this is 2 the square root of 2. Therefore, by Pythagorean theorem, your h will now be the square root of 6 squared minus 2 the square root of 2 squared. Or that will now be the square root of 36. 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8. 36 minus 8 is 20. 28. So h is the square root of 28. And since you now have the value of h, just go back in this equation, substitute the value of h, then you're done. You have the volume of the regular square pyramid. Again, this is in your module. There are still some solved problems in your module. Please try to review those problems, learn how the values were obtained. Anyway, the solutions there are given step by step. Just base it from these two examples. And then there are also some problems there that you will find as supplemental problems marked as homework. Please do them also. So after this, we will have the next section of module